So now let's get on to exponentials and logarithms. Let's just have some definitions first. The definition of an exponential function is a function in which the independent variable is only the exponent of a number. For example, if a y equals 2 to the power of x, then this is an exponential function because this independent variable x is in the exponent of the number 2. And if you want to write in function notation, you have f of x, which is a function of x, equals to e to the power of x. This may be the most famous exponential function. This e here is just a number like 2. It's basically a constant and an irrational number like pi, and mathematicians just prefer to write it in this exact form. And exponential functions are useful in the rough modeling of population growths. So if you have like something like cell division, you can modulate using exponential growth. And also probabilities and the radioactive decays. The next one is a logarithm of a base b. You need also to specify this another number, which is the important parameter of a logarithm. So we denote it in log b of x. And this tells you how many times b must be multiplied to itself to give you x. And so written in maths formula, this tells you that if a is equal to log b of x, then this implies that if you raise b to the power of a, then this will be equal to x. Now this expression may seem a little bit hard to understand, but don't worry, I'll give an example, an easy one. So if you have a log in the base of 10 of 100, this will give you 2. This is because if you take 10, so this base to the second power here, and you get 100. So it's basically the 2 tens times together will give you this. And there's some caveat here. If b is not written, then the base is assumed to be 10. So if you just see log of x, then this means log in the base 10 of x. And if the base is e, this number here, which has an approximate value of this, and we use ln instead of log. So if you see ln of x, then this means the log of x in the base of e. So next, after definitions, let's talk about the laws of it. The exponential laws are basically the same as index laws. Just now the base is a constant and the exponent is a variable. So we will not talk about that. The thing we are going to focus on today is log laws. And you need to be aware that the base of a log must be positive, and it can't be equal to 1. And the thing x and y, the numbers you put in the log, must also be greater than 0 as well. So the first one is a very useful property. You have a log of 2 numbers times together, then log laws tells you that you can separate the numbers into the log of individual numbers and then plus them together. This property of logs is actually why logs are invented and used in the first place. Because back in the old days where people don't have calculators, and the astronomers, when they are doing great distance calculations, it's very hard and tedious to multiply 2 very large numbers together. And so they just invented logs. If they have 2 very large numbers times together and they need to take the product, they just take the log of that product, and then they can basically separate this product into an addition. And the log of a number will be generally much smaller than numbers. And there's actually pre-made log tables. You can just look up for the values of a log of a number. So in this ways, if you take the log of a large product, you can basically turn it into a simple small number addition. And enough of history, let's get on to log laws. The second one is very similar. It's just you have division instead of multiplication, and it's basically the opposite thing. You just swap this addition sign into a subtraction sign. The next one is a fact you need to remember. Log of any base b of 1 is 0. So this is because b to the power of 0 is 1. So you have this identity here. And next identity is log of base b of b is 1. And this is pretty obvious, as b to the power of 1 is just b. And next one is a pretty useful property. It basically comes from this. If you replace y with x many times, and so if you have x to the power of k, then you take the log. The log loss tells you that you can just pull out this k in front of the log. And so this means that, for example, anytime you have a log of a number cubed, this will be the same as 3 times the log of that number. And next one is another trivial but actually useful fact. If you have b to the power of log in the base b of x, this will be the same as x, which is also the same as if you take the log in the base b of b to the power of x. So this b and log b basically cancels out. It's similar to when you divide and multiply by a number at the same time. You just didn't do anything, you get your x back. This may not seem to be pretty useful now, but it will actually become very useful when you start doing calculus. And the last one is called the change of base formula. You probably won't have this in your exam, but I thought it's helpful for you to know that, as you may need to use it someday. The law says when you have a log in the base b of a number x, you can divide it by the log in the base b of another number c, and this will basically turns the base b into base c. Now that's all the laws you need to know for exponentials and logarithms. Let's do some example questions to get you familiarized with these laws. First one is to factorize e to the power 2x plus 2ex plus 1. So upon seeing this question, the first thing you can notice is that you can actually rewrite this expression. So you can see that e to the power of 2x can be written as e to the power of x then squared. This is because from index laws, you know that when two numbers are multiplied together on the exponent, then its effect is same as you take the base to one of the numbers to that power first, then take the power to take it to the power of the other number. And now you can actually observe this in quadratic form. If you haven't seen that now, I can just let u equals to e to the power of x. Then this expression can be written as u squared plus 2u plus 1. Now you see it's certainly a quadratic, and it's actually a very nice quadratic because it's a perfect square. It's just actually equal to u plus 1 squared. So you know from perfect squares that when you have the number a plus b squared is same as a squared plus 2ab plus b squared. In our case, a is just u and b is 1. And the final step is just substitute u equals to ex back in, and then you get your fully factorized expression. And I have done this substitution just to make clear that it's a quadratic expression. If you are very confident, you can just jump straight from this step to this step. But now, that's all for the exponential questions. Now let's get in some log questions. I put in more log questions here because I think it's better for you to do a lot of questions to get you familiarized with the log rules. The first one is very easy. It just tells you to find this thing, very straightforward, log of square root of 10. So we can just record that whenever you have a log without a base written, you can assume it to be base 10. And also square root of 10 is basically 10 to the half power. Anything square root, you can rewrite it as the thing to the half power. And then the log of base 10 with this 10 base, it cancels out, and then all you left is a half on the index. Next one is a show that question, so we need a bit more working outs. It says show that log of 20 minus log of 2 is 1. So upon first seeing this question, obviously there's not much you can do on the right hand side, but for the left hand side, because this 20 here and this 2 here, these two numbers are different, which don't give us much room to working. So the first thing I will do is I will write this log of 20 as log of 2 times 10. And then by the property of the log, whenever you have two numbers times together in a log, you can separate them. It will be equal to the log of the individual things plus together. And you can see the log of 2 with this minus log of 2, they cancel out straight away. and all you're left with is log of 10. And basically 10 is the same as 10 to the power of 1. So this 10 log cancels, and it left you with 1. This is exactly the same thing as the right hand side. And the third one is to write 2 ln 3 plus 3 as a single logarithm. So because the question tells us to write a single logarithm, these 3 obviously can't stay, so we need to rewrite it. We can record the identity that ln of e to the power of anything is just equal to that thing itself. So we can just write 3 as ln of e to the power of 3. These two things are basically the same. And for the term before, 2 times ln of 3, if you record that identity, whenever you have a number multiplied in the front of a log or ln, you can just move that number to the inside of on the index of that number. So it will be equal to ln of 3 to the power 2. And then you have the same ln here. You can just merge them together and put them into a multiply. So it's 3 squared, which is 9, multiplied by e to the power of 3. It's an irrational number. You can just leave it in this form. And now you have written as a single logarithm. So that's all for today. Thank you guys.